I'm Tim Barkley with Charleston Home and Design Magazine, and today we're talking with Dean Paulk with Energy One America. How you doing, Dean?
Doing great.
Good. Dean, we're out here in the Ion subdivision in Mount Pleasant, and you're going to be taking us on a tour of a new home that's currently under construction that Energy One America is providing some closed cell foam insulation. And why don't we, before we go inside, why don't you take a moment and just tell us all about Energy One America?
Okay, thank you. Energy One America, we've been in business now for going on 9 years. We've recently had a name change. We were U.S. Home Protect, but because we've been growing and we've moved into some other markets, we wanted to kind of get a lot of continuity with our name. And the Energy One America name just kind of identifies us a lot better than our previous name of U.S. Home Protect. It kind of sounded like we were an alarm system company. So we wanted to get away from that. But we've been in business about 9 years. We do three things, and we do them really well. We do spray foam insulation, we do closed crawl space encapsulation, and we also do mold prevention through a process of FortiCell, which gives a 25-year warranty against mold growth in a new construction home.
Gotcha. And are there any other type of insulation that Energy One America also does?
Well, we primarily do the two insulations, open cell and closed cell insulation. We will do some batting insulation. We primarily do the spray foam though. The batting insulation is usually going to be used for mid-floor sound or interior wet walls.
Okay. And for this this home here in the Ion subdivision in Mount Pleasant, what kind of scope of work was Energy One America involved in?
Well, we're going to pretty much do the whole envelope on this home. We're doing a closed crawl space encapsulation for this home, as well as the entire envelope of the home. We're doing closed cell insulation on the roof decks, and we're doing open cell insulation for the exterior walls.
Okay.
Some batten insulation mid-floors for sound abatement.
Okay, sounds good. Well, let's head on inside and take a look at the project already in progress.
Sounds good.
Okay, Dean, tell us where we are and what we're looking at right now.
Okay, we got Mike, one of our top spray technicians, up in the roof rafters here. He's spraying the roof deck. As you can see over here, in the soffit areas where you see some daylight coming in, we've stuffed these areas with fiberglass insulation. That's to prevent the overspray of the closed cell foam getting out of the house pocket and out to the exterior of the home. We don't want to get any overspray on the outside finishes.
Yeah, they're putting some nice brickwork on the outside, so you don't want that spray foam to get all over the brick, right?
Exactly right. So we stuff the eaves of the soffit here with the fiberglass, and then what he'll do is he'll bring the closed cell down and encapsulate that fiberglass behind the closed cell foam. Now, one of the more important things that we do as a company is when we're done with this job, we'll do a blower door test. And what that'll do is that'll negatively charge the house with a 20-mile-an-hour wind, so that if there's any pin-sized hole that we have missed, we'll find it through the blower door test and come back and touch those areas up. So that's one of the things that sets us apart from a lot of people in the industry, is that we do that, and we do it not through our own company, we do it through a third party, because we don't want to be testing our own work. We want to make sure that it's a legitimate test, and if there's any things that we've missed, we want to catch it at this point of the build out.
Dean, why is it important to spray foam the attic area of a home?
Well, the great thing about spray foam is we're gonna take this home, instead of doing a vented attic assembly, we're going to be doing a closed attic assembly. So the spray foam, as you can see, goes right up underneath the substrate of the roof. So now the attic assembly itself becomes conditioned space with the rest of the house, so that the HVAC unit comes inside that conditioned space, so it no longer sits in a superheated attic area where most attics typically in the South can get up to 140, 150 degrees. Well, your HVAC has to be able to work through that hot temperature. In this situation, because we're going to be conditioning the attic, essentially because of the closed attic assembly, the HVAC system will be in a much friendlier atmosphere for it to work. So it'll work longer, it'll work with less stress on it, so it should increase the longevity of the HVAC unit. And if you plan for this at the beginning of the build-out process, you can downsize the HVAC unit and save some money there as well.
Now, Energy One America is putting closed cell spray foam insulation here in the attic, And then will you be putting closed cell spray foam insulation anyplace else in the house besides the attic area?
Yes, we are going to be shooting the subfloor of the living space above the garage area. It's a very important area to hit. Typically, we call them frogs or bonus rooms above garage areas. Typically, in conventional construction, that's one of the coldest rooms in the house during the winter and one of the hottest rooms during the summer.
Because it's right above the garage, which usually isn't heated or cooled.
That's absolutely right. And you get a lot of wind draft as the garage doors open and close. You get a lot of wind movement through the garage areas and through the subfloor. By using closed cell spray foam in that subfloor, we're going to eliminate that air movement, and it's going to be a much better insulated process.
Now, you were mentioning, talking about, you used a term, the envelope of the home. What does that mean?
Well, essentially, it's just the exterior, the outer perimeter of the home, whether it be the roof assembly, whether it be the exterior walls, whether it be the subfloor. Anything that is the outside substrate of the house, we call that the envelope.
Okay. And if, I'm not sure where the term originated, but I guess I always kind of look at it as when you get an envelope, when you get a letter in the mail at home, sometimes the envelope is completely sealed and it's kind of difficult to open, with your fingers, and sometimes it's very loosely sealed. And how does that relate to a home, that analogy?
Actually, it relates very well. Completely sealed is what we're going for. Loosely sealed can be very, very bad. And in this industry, one of the things that we run into is that there are several companies out there that, for lack of a better description, are two men, a dog, and a truck. They've gotten into the industry and they can spray foam, but there's really a science behind it. And if you're not very careful, you can create a problem in the attic assembly. If it's not 100% sealed and sealed tight, then humidity, moisture can get into that attic assembly and can cause real problems. There's a lot of companies out there that we've actually gone in and repaired some of the work that they've done, and that third-party blower door testing has been a big, big benefit to us in making sure that we're doing everything completely right.
The blower door test, that should be something that maybe a homeowner should insist on if they're looking to maybe hire a company to have spray foam insulation installed in their home.
Oh, absolutely. Definitely insist upon it. The thing about it is when you do a closed attic assembly with spray foam, if you get it 99% right, that 1% will come back and bite you. And that's what the blower door test will do for you. It will ensure that it's 100% right and not nothing's missed.
Now, what's the homeowners could have chosen open cell spray foam insulation. What's the difference between open cell and closed cell, and why do you think they chose closed cell for this particular project?
Sure. The biggest difference between the two foams is they're both give you the same thermal protection properties. They're going to give you the same conductive heat reduction. The biggest difference between the two is closed cell foam is actually going to add structural integrity to the home. You're going to increase your racking strength in a wall by 2.5%, or 2.5 times the racking strength, which is about almost 300%.
You're throwing some jargon around that our listeners, viewers, and readers may not be aware of. Now, when kind of describe that in if you're talking to a homeowner.
Well, essentially what we're going to do is we're going to glue this house together. So they've actually done some testing in Florida in hurricane strength winds where they've taken conventional framing techniques of just nailing a roof together and identical home, identical roof line, and they've used just closed cell foam, no nails. And the closed cell foam outperformed nailing the roof down in hurricane winds. The roof that was nailed actually blew away in the hurricane force winds. The roof that was spray foamed with closed cell foam stayed intact. And that just speaks to the integrity of the strength of closed cell foam.
So the in addition to saving the homeowners money on energy costs and having a more comfortable feeling home because of the closed cell spray foam insulation, they also have the added benefit of us being in South Carolina. The threat of hurricanes are always present. It strengthens the roof and kind of, as you said, glues all of the the roof rafters together so that with high winds, it's not going to be able to rip a roof off a home as it would if it didn't have the closed cell spray foam?
That's correct. It's 2.5 times more stable, more strength given to the home using spray foam, closed cell spray foam. There are a lot of insurance companies now that are seeing the value in closed cell foam. They're actually giving steep reduction in homeowners insurance for using closed cell foam.
Now, as I mentioned, these homeowners could have chosen open cell spray foam insulation. What is that as compared to closed cell?
Well, the open cells, again, is going to give you the same thermal properties, protections. The benefit that open cell, the added benefit above and beyond the thermal properties, is that open cell is a great noise abatement product. They use that a lot in sound studios. If this house were to say in line with a runway and had airplanes flying over it on a regular basis, open cell would be a great solution to help dull the noise down inside the home. So it's great noise abatement. Now the biggest difference between the two is closed cell is a true vapor barrier. No moisture is getting through the closed cell. Open cell is a vapor retarder, so moisture can eventually wick through an open cell product. So if you have a penetration in the roof, water gets in, the closed cell is going to make sure that water doesn't get into the living assembly. Open cell, that water will eventually wick through. You'll find the leak, you'll be able to rip that open cell foam out of the way and repair the leak. So there's pros and cons to both sides of the point on that.
Right, and some of the critiques of closed cell is you don't really discover the leak until it's a big problem, right?
That's correct. If you do get a penetration in the roof and water does get into the area between the roof substrate and the closed cell foam, it can puddle. If that happens, there's the threat of you not discovering that leak and it rotting that area out. The likelihood of that happens pretty slim because, as you see how he's applying it, this goes on like paint and it adheres to the substrate, so there's not very many voids behind the spray foam. So if you get a penetration, water does get in there, it doesn't travel very far because the way the closed cell foam adheres to the substrate. So that isn't a fear that I put a lot of stock in.
And they've already put the roof on the house, so there won't be any additional screws or nails that are put into the roof sheathing.
That's correct.
What about a retrofit? 'Cause I know Energy One America is able to spray foam existing homes that may have very little insulation. I know you do a lot of work in some of the historic homes downtown that have virtually no insulation. And how does Energy One help homeowners retrofit houses?
That is definitely one of our areas that we excel in, is retrofitting. If it's a completed house, obviously the sheetrock prevents us from getting to the walls, but you can get a lot of energy savings just retrofitting the attic and crawl spaces of homes. And depending on, every home's unique, but depending on how old the home is and how long the fiberglass insulation has been in the attic, we can remove that insulation and spray foam either open or closed cell and give you a much better thermal envelope of the attic assembly. And again, bringing that HVAC system into a conditioned space is going to help increase the livelihood of the HVAC system, and it's also going to help to drive down your energy costs.
And it's usually, an attic is usually pretty accessible to your crew if you wanted to get up there to spray foam the tops of the rafters. If you walk into your own attic, it probably looks something like this, where you see open rafters like that. So it's not really that difficult. It's not like you'll be tearing out walls to put in spray foam insulation in the attic.
That's correct. But again, every house is unique. There's some areas that we don't have good accessibility, we can't get to. In those areas, we're able to cordon off and just spray the areas of the house that we can, and the areas that we can't, we can always close those off, so you can at least get a partial benefit from a closed assembly in the attic.
And correct me if I'm wrong, but I've always heard that if you were to prioritize where you were going to put spray foam insulation, the number one place would be the attic area. Is that right?
Absolutely. The biggest culprit for energy theft is the attic. That's where your air is going to escape from the home more readily. Second place would obviously be the subfloor. And then if we do have access, third place would be the walls.
And subfloor being the under the crawl space area, the area underneath the house.
That's correct.
Good deal. And you just mentioned that your spray foam technician is getting a little close to us, so we may have to move to avoid any. And I see he's in a protective suit, so you're obviously taking a lot of precautions to make sure that he is protected, doesn't get any of this is this spray foam. And that's probably a good question. Is the spray foam insulation, is it harmful once the homeowners move in? Is there any kind of off-gassing or any hazards related to that?
That is actually an excellent question. The great thing about spray foam insulation is there's 0 VOCs. The reason for this...
What's a VOC?
I knew you'd ask me that. Volatile off-gassing...
Volatile organic compound?
Thank you very much. Volatile organic compound. There is no volatile organic compound, so there's no poisonous off-gassing of fumes from the spray foam. The reason he wears the suit is obviously we don't want to get it on our skin. As I said, this stuff, it adheres. It's like glue. And it can be painful to try to remove from your skin if you get it on there. So he keeps the suit on. And also the protective wear, you see he wears a mask and goggles. This foam expands about 170 times per second. So it goes on like water and it expands 170 times per second. If you were to get that in your eye and that expansion were to be taking place in your eye, you can imagine the kind of pain you'd be in. So we take lots of precautions to make sure that we are completely safe in what we're doing.
All right. Well, let's relocate to another spot here and we can continue our interview. Okay, Dean, now we are in the upstairs, the attic area of this house, and we're getting kind of a close-up look at the spray foam insulation. And what's this instrument that you have in your hand?
Yeah, this is probably the greatest tool that I have for this type of work. The big issue that we have here is we want to make sure our depths are right. Well, how do you measure something?
Depth of what?
The depth of the foam. Okay. So how do you go about measuring this depth of this foam that's a solid mass that's on the roof deck here? This is the greatest little tool. This little needle here, I just take this, plunge it into the foam, slide the plunger down, and it gives me my mark. And it shows me that I'm a little over 3.5 inches. So our guys are doing an excessively good job here because we want a minimum of 3. So we're at 3.5 here, and we can just check various areas. We always want to try and check the lowest area, like for right here. We may want to come back and see if this needs to be hit, but no, we're good. We're 3 inches there too. So even in our low areas, we're at 3 inches is what we're looking for. Now on the walls, this area, we only need 2 inches in the wall pocket. So we can check this also and see how it's doing here. And again, we're just slightly less than 3 inches. So we're good here. Okay, so that's what we're looking for. Walls with closed cell foam, we're going to be at 2 inches. Roofs, we're going to be at 3 inches.
Do you ever get a homeowner ask you, why didn't you just fill this entire cavity with the spray foam? Did I get shorted, or did you not put enough insulation in? It seems like it ought to come. And I've seen, like, I remember This Old House episode where they took out, after filling the void with insulation, they took out an old handsaw and actually cut down so that it was flush with the 2x6s.
That's an excellent question. Yes, we get that asked quite often, actually. Obviously, framing members come in different dimensions. If we had a 2x4 wall here and we were using open cell foam in a wall, we're going to shoot 3.5 inches. Well, 2x4 nominal size is 3.5 inches. Very, very difficult to keep the foam from expanding past that 3.5 inch mark, so sometimes we will have to trim it down. Now closed cell, because it's a much denser product, 2 inches is all we need, so we very rarely have to trim the closed cell product. If we're trimming closed cell product, then we're not being very
efficient on your own end of the business.
Exactly. So when we're looking at a roof deck like this, when we do 3 inches, and again your question is why don't we fill this whole pocket? You're going to get a conductive thermal heat resistance of about 96.4% with 3 inches.
No, you just threw some big terms at us. Wait, can you say that again?
Sure. It's called conductive thermal heat resistance. In other words, how much resistance am I creating of the energy loss through the roof? I'm going to be able to block 96.4% of my energy loss from getting out of my roof with 3 inches of closed cell foam. If I were to spray up to 10 inches of closed cell foam, I could only max out at 98%. So for that extra 7 inches of foam, I'm only picking up less than just over 1.5% of my conductive thermal heat resistance.
And yet you may have to charge a customer 2.5 times the normal charge.
Exactly. So the chemical itself is the most expensive part of the application. The labor in comparison is cheap compared to the cost of the actual chemical.
And spray foam is a petroleum-based product, so it kind of rises with the gasoline prices.
Correct. So if I'm able to achieve 96.4% reduction in my thermal loss at 3 inches, there's really not much benefit of going deeper than 3 inches. If the customer insists on it, we're more than happy to accommodate them, but it doesn't make good financial sense. There's a point of diminishing return for your money, and that 3-inch mark is that point.
What does code require?
Well, that's an interesting question also. Code is still catching up to the industry of spray foam. There's a lot of code officials, a lot of architects out there that are still they're kind of tripping over the R values. For example,
what is R value?
R value is basically just a laboratory term that says if I have a hot plate in the laboratory and I've got a cold plate and I put a substance in the middle, usually fiberglass insulation, how long does it take for my hot plate to raise the temperature of my cold plate? And that gives you an R value. It's a laboratory expression of temperature. With spray foam, in comparison to fiberglass is just that. It gives you an R value, which is only that temperature differentiation from the hot plate to the cold plate. Does not take into account air movement, does not take into account moisture movement, which are the two biggest culprits in our climate, at least, for energy efficiency. What spray foam does, it gives you the R value, but it also prevents air movement and prevents moisture movement, which are the two bigger culprits. And because they prevent that, it's a much more efficient product than just fiberglass insulation. So the problem is that for 75 years now, we've been using the R value to determine what our insulation value should be. A more accurate determination would be, to use that big term again, is conductive thermal heat resistance. How much conductive thermal heat resistance do I have in my product? Our 3 inches of closed cell foam will give you about a 19 R value. Well, code requires an R30 in most attic assemblies. My R19 of closed cell foam will outperform an R30 fiberglass 8 times over. So at R19, if we're outperforming the R30 requirement, we can show that performance exceeds what code is requiring. And that's how spray foam is able to be used at a much lower R value.
And let's kind of use a comparison. We're recording this interview in early November 2011. Let's jump ahead, 6 or 7 months. Let's put us in the middle of summer 2012. What will it feel like as we stand up here in the attic area of this home?
Well,
in the summertime.
In the summertime, whatever they keep their house at, most people are going to keep their house around 72 degrees. The attic assembly won't get, with closed cell foam or open cell foam, if it's a closed environment, the attic assembly will stay within 10 to 12 degrees of the living space. So where this attic would typically be 130 to 145 degrees, it should stay between 80 and 85 degrees.
And so if it had the traditional fiberglass batt insulation in here, even though that fiberglass has an R value of 30, it would still be roasting hot up here, right?
Exactly right.
Okay. And whereas with the R value, you said R19 for spray foam, it's going to be maybe 10 degrees hotter than the conditioned space in the house. If it was 78 in the house, it might be in the 80s in the summertime up here in the unconditioned attic space.
That's correct. And more importantly, we're also going to keep the humidity out of the attic space. If you go up into your typical attic where it's 135, 140 degrees in the middle of summer, you're up there for a very short period of time before you bust out in a sweat because of the humidity that's in that attic as well. In the south, we have high levels of humidity around here. So if we're able to keep that moisture, which moisture in a house is a very bad thing, so we want to keep moisture away. Closed cell or open cell foam in the attic assembly is going to help do that as well.
And so when you were you were talking before about basically the sun is beating down on the roof of this house, and the heat is conducting through the roof and through the fiberglass insulation, and that's what creates the heat in your attic in the summertime, right? It's created by the sun beating down on the roof.
Correct. There's basically three types of heat transfer. You got conduction, convection, and radiation, and you're getting all three of those in the attic assembly. The spray foam insulation reduces or eliminates all three of those.
Gotcha. So that is what will help on the energy costs here in the home. The homeowners won't have to run their air conditioning as much during the summertime, and they'll just feel a lot more comfortable, cooler with the spray foam insulation. It seems like a no-brainer. So Energy One America is also spray foaming all of the walls in the house all the way down, or will they be using a different type of insulation for the walls?
We'll be doing spray foam in the walls as well. We're going to switch to open cell in the exterior walls. We're looking for the structural integrity in the roof by using the closed cell. Now, closed cell is generally a more expensive product, about $1 a square foot more expensive than open cell. So as we drop into the wall cavity, we're looking for noise abatement. We're also looking to help reduce the cost of the insulation, so we can switch to open cell in the walls. We get the same thermal properties, but we get it at a less expensive price point, and we also get noise abatement from traffic and noises outside of the house.
And then what about in the crawl space underneath the house? What will Energy One America be? What kind of insulation will you be using there?
There we're going to be doing what we call an encapsulation. So what we do is we go in, we put a 20 mil vapor barrier down on the earth, so double sealed. We come up the foundation walls to within 12 inches of the outside grade. And then on the outside of the foundation walls, where in this case, I believe we're using Thermax. It's a rigid foam board that adheres to the foundation wall, and it insulates. What it does, it's essentially is we're going to bring the envelope of the house all the way down to the earth, through the top plate, down through the foundation walls. So now the earth actually becomes our insulation. So there will be no insulation in the subfloor itself, because the earth provides that insulation for us. So we just insulate the foundation walls. And when we do that, the crawl space has to be conditioned. There's two ways of doing that. We can do it with a dehumidifier, or they can actually condition the crawl space with the HVAC system, so it conditions the air and dehumidifies the air. And there's two different ways of doing it.
Gotcha. Okay. So just kind of summing it up then, tell our listeners, viewers, and readers exactly what the services are that Energy One America is providing for this new house.
On this house right here, we're providing a complete thermal envelope of closed and open cell foam, as well as a complete closed crawl space encapsulation. And then the third thing that our company also does is mold prevention through Forticell.
Do they have Forticell in this house?
This house has not chosen to go that route, but it is always an option.
And what does Forticell do?
Forticell is a spray-applied product that we put on the framing members of the house, and it gives a 25-year warranty against mold. Typically what happens in most homes, what this is going to do is going to give you basically an insurance policy against mold being created inside the wall pocket or against the framing members of the home. If there were ever to be a flood incident, whether it be a leaking dishwasher or a bathroom area, if you have a window that is left open and rains in, if it's a vacation home, a lot of times we see some type of water incident into that home. If there's an area where mold is created, the Forticell will prevent that mold from being able to germinate and create. A lot of times what you'll see is in bathrooms, laundry rooms, kitchen areas, around windows, the sheetrock will start to present mold. Well, the sheetrock can be fairly easily remediated. The problem is if it's left unattended, that mold can translate into the framing members of the home. And once that happens, then you can get into a lot of expense for making proper remediation. The Forticell is going to save you that expense, because the Forticell will not allow that mold to carry into the wood members, and it will not be able to germinate past that sheetrock area.
Are there options with Forticell where a homeowner might decide to have you spray the Forticell on some of the wet areas of their home versus all of the entire house?
Absolutely, yeah. Forticell is something that we do in different varying degrees, starting at a bronze level, which would be your window areas, your wet wall areas, 3 foot from the floor up 3 feet, around the penetrations of doors and windows. Then we go to silver, gold, platinum levels of Forticell application. The platinum level is every stick of wood in the house is treated, so that if ever there was a mold issue anywhere in the home, you know that you're protected.
Good deal. Okay. Anything else you'd like to add about this job here in Ion?
It's just this is one of our favorite places to work here in Ion. The Mount Pleasant area is and the Ion area are great home builders out here. Cook Bonner, one of the premier home builders, and they're doing a great job. And we get a lot of call out here for our products, and we're happy to accommodate them.
Good deal. Well, tell everybody how they can get in touch with Energy One America.
Absolutely. My name's Dean Polk. My phone number is 843-957-8130. Feel free to give me a call. I'll be glad to help you out with any kind of a quote or estimate. Or else you can also visit us on our website at www.energy1america.com. The one is spelled out O-N-E.
Okay, good. Well, we have been talking with Dean Polk with Energy One America here in the Ion subdivision in a brand new house under construction. Thanks so much, Dean.
Thank you, Tim. Enjoyed it.